Welcome back to the OpenVINO channel. On video 47, we saw how to install the GStreamer video analytics. Basically, we've added analytic elements to the pool of GStreamer elements, so now you can use inference operations in GStreamer pipelines. Now, I'd like to show you some more samples and tricks on how to use it. Last video, I showed you a shell GStreamer sample that looks like that. But we also have C++ samples. Let's look at the face attribute sample, for example, under GStreamer Samples /CPP. We can just run the built-in run, and you can see that it's again a full application with multiple face-related models. Looking at the code, you might need to change the location of the video file, and you can see that it's pretty detailed. Maybe it's easier to code and run the shell scripts, but these C++ samples can give you more details and can serve as a great reference code you can just copy to your application. Let's quickly look at the other shell samples. This is the GStreamer execution line for console measure FPS CPU. As you can see, we read the video file, we decode it and convert it, and we are performing detection on the CPU with batch size of 1. We can have the option to skip frames. Here we're running inference on each frame, and then we present the FPS to the screen. The code for running on GPU, the console measure FPS GPU, has two things to note. One, the VAPI, the VA, Video Analytic API driver environment flag, is set to 1, telling GStreamer to use the GPU driver for decode and other operations. 2, you see that the inference run on GPU, device equal GPU. Another interesting example is vehicle detection two sources, CPU or GPU. It is really two pipelines. This is one pipeline, decode, convert, detect, display, and this is the other pipeline. What is interesting is that they both have the same inference ID, so these inferences could be treated as one entity, and the parameters like batch size, etc. could be specified only in one place. And this is the last sample I want to show you, the face detection multi-channel. You can see here a string called pipeline_str holding a full pipeline with detection. And here is a loop that adds to this string more channels, as many as you want, 2 in this case. So when you actually run the GStreamer pipeline, you get multiple channels working together. Just for the demonstration, I've added a display to the multi-channel face detection. You can see here the base string with the display option that I added. This will be duplicated 2 times in here. You can see the decode, the convert, the detection, and you can see that the inference IDs are the same. I run it and you see face detection working on 2 streams in parallel, and I can add as many channels as I want very easily. So basically, if I can afford 20 frames per second, I will keep on adding channels until the performance will drop below 20 FPS. So this is a very powerful tool for creating pipelines and benchmarking them on multiple platforms. If your product manager tells you, I need to stream X channels at Y FPS and run inference using these deep learning models, just build a pipeline. It should take you an hour and run this pipeline on multiple platforms to measure the performance. There are many more things to talk about the GStreamer plugin. Please read the full documentations for more details or ask questions in the forum. Thank you.